first section, in order to find out the first section moment of inertia. So for rectangle, this is a small geometry figure, so very well known figure. So that's only directly we are having about the base axis, that is x-axis itself only. It is the base axis, x-axis for first section only. So assuming it is a full geometry, there is no portion that is removed. So that's why only on that assumption we are going to find out the moment of inertia. So for first section, that is Ixx1. So x is nothing but base axis only. So this is your x and this is your x, about the base axis only. So here they have mentioned in the problem that, so of the given figure, about the base they have to mention about the base, not about the central axis. If they have central axis, it is different. So directly you can go for BH cube by 12 formula. Okay, but here they have mentioned about x-axis. So x-axis is where we are having in the problem. So here we are having the problem. So there about the x-axis means, so Ixx1, which is equal to, for 1 means your first section, 1 means your first section, which is equal to your, directly we are having the formula, so as BH cube by 3. So how we got this formula? Actually by doing this expression from parallel axis expression only we got this formula. Either you can go for directly getting the BH cube by 3 formula, or otherwise you can go for this elaborated formula. So Igx1. So from both the formulas we are going to get the same value. So directly we can go for BH cube by 3. So base is 240 for first one rectangle. So height is how much? 120. So divided by 3. So if you do this, you are going to get as 8 into 10 power 6. 8 into 10 power 6. So if you want to know how we got from this formula means, so I will explain here. So Ixx1, or otherwise you can go for applying this formula also, Ixx1, which is equal to, so central axis. So central axis is nothing but your BH cube by 12. So that is this one. So that is this one, Igx, central axis plus area of this one. So area is nothing but your B into H, and distance between these two. So distance between these two is nothing but your H by 2. So whatever the height of the rectangle is there, so I personally assumed as H before. So it is H by 2 whole square. H by 2 whole square. If you go for BH cube by 12 plus H square by 4. So BH is outside of the bracket into H square by 4. So if you do this, so 4 BH cube plus 12 BH cube, that is 16 BH cube divided by 12 into 4. So 4 is 16 and 4 3 is 12. 4 3 is 12. So directly we are going to get as BH cube by 3 about the base. So that's only we have applied this formula about the base axis. We have applied this formula about the base axis, that is 8 into 10 power 6. Okay, so now I will erase this. Now we got 8 into 10 power 6, 8 into 10 power 6 per moment of inertia of first rectangle. Now second section is somewhat tricky. Section. So see here, that is your quarter circular, semicircular area. Observe, this is it. Actually, the base of the semicircle. This is the base of the semicircle. So let us suppose for assume the starting point and end point of diameter of this circle A. Okay, but I want to find the moment of inertia of this one in order to subtract. I want to find the moment of inertia about base axis only. So in order to find out this one, first of all, go for finding out the centroid. So somewhere I'm having the centroid. So this is the centroid of this one. But what is the somewhere means exactly it is from the base of this one. We are going to have the value of 4r by 3 pi. 4r by 3 pi. Exactly 4r by 3 pi. So centroid will pass through the this is the central axis. So Gx are the central axis for this semicircular area. Okay. So if I want to find out about the moment of inertia about this one, first of all, I have to find out the moment of inertia about base axis. About the base axis first of all. So whatever the moment of inertia about this base axis, why I have to find out this one, or why I am not able to find out this about the base axis. So first of all, in order to find out the moment of inertia at the base axis, try to find out moment of inertia about this GX axis. I don't know about GS axis, moment of inertia. Okay. If I want to find out moment of inertia about base axis, that is Ixx2, which is equal to moment of inertia about Gx, okay, plus area of this thing with the h2 whole square, h whole square. So this Igx is nothing but this one. So area of this one plus h is this one, height is this one, 4r by 3 pi. But I don't know the moment of inertia of Igx. So first of all, I want to find out the moment of inertia of this Igx. Plus afterwards, I want to add this area into h square. Area into h square. So that's why. So I'm going to see here. First of all, I will find out the moment of inertia about central axis. About central axis. Okay. So central axis Igx. So first of all, Igx moment of inertia of a quarter circle. So that is x2. I will call it as why because it is the second section, you know. So that's only moment of inertia of base axis. Okay, minus area of that thing into h2 whole square. So why we are getting like this? It means see here moment of inertia about base axis is your IAB. First of all, in order to find the moment of inertia about central axis, this total entire, so this one about this base axis, if you want to find out moment of inertia, more clarity. What is my base here for semicircle? If this semicircle actually in this shape, if it is not reversed, we can go for finding out. So first of all, actually see here, semicircular area like this, AB is this axis and the centroid. I am assuming if it is like this, so this is actually 4r by 3 pi, whatever the h value is, 2 pi. So this is centroid axis. This is also x axis, x axis. So if I want to find out the moment of inertia about central axis means, or otherwise about base axis means about base axis. Base is my AB, you know. About the base axis directly, I am having the formula as pi r power 4 by 8. If you remember this formula, have you remember or not? If you remember this formula, this is pi r 4 by 8. But if you want to find out the moment of inertia about base axis, central axis, Igx is your central axis, which is equal to IAB minus your area of that particular geometry into h2 whole square. Why? Because base axis IAB base axis is equal to centroidal moment of inertia plus area of that particular thing into square of the distance between those two parallel axes. But we don't know the value of this one, but we know the value of IAB. So from the proof we got IAB value as 4 by 8. So if you come to left hand side, whatever the value is there, so that will be subtracted. I will get the moment of inertia about central axis. So that's why I have to first of all find out the moment of inertia of central axis. So by subtracting A to H2 from IAB, I'm going to get the moment of inertia of central axis. Is not just find the moment of inertia about central axis. Okay. So that central axis I G X 2 for second figure, which is equal to IAB minus area of semicircle and square of the distance between those two. So this IAB is nothing but your for quarter circle it is pi r power 4 by 8. We know already, and area of this particular quarter circle is how much? This is your A2 quarter circle. Pi r square is your total circle. So divided by 4. Sorry, divided by 2. But because it is not a quarter circle, it is semicircle into area into H2. So what is the H2 here? H2 is the distance between your central axis and your base axis. Now my base axis for this quarter circle, semicircle is this. AB is my base. AB is my base. So this is AB, this is AB. Whatever between here to here, this is 4r by 3 pi. Just go for 4r by 3 pi is a perpendicular distance, or other is distance between these two parallel axes. One is my AB axis, another one is my GX axis for quarter circle. Okay, so 4r by 3 pi whole square. 4r by 3 pi whole square. This is the distance. If you do this, so pi into r is how much here? 100 or otherwise 90, sorry. So r radius of this one is 90 mm. So where I have given, so here I have mentioned as 90. So pi r power 4, 90 power 4 divided by 8 minus pi into r square 90 whole square divided by 2 into 4r by 3 pi. 4 into 90 divided by 3 pi whole square. If you do this, you are going to get as, so here, how much you are going to get? So I am going to calculate here, calculate it. So if you are having any calculator, calculate it. So before I calculate the value, so pi is how much? 3.14 into pi into r power 4, 90 power 4 divided by 8 minus pi into minus pi into pi r square. Pi into r is how much? 90 whole square divided by 2 into how much it is? 4r by 3 pi. 4r by 3 pi. 4 into r is how much? 90. 4r divided by 3 pi. 3 into 5 whole square. This is for 1. So 71,88092. So this value totally I got after calculating 71,88092. Okay, this is IGX2 value. This is IGX2 value. Central axis. Okay, central axis. But see here, but I want to find out the moment of inertia about this x-axis, x-axis, not about the central axis, not about the central axis. So for that purpose, what I am going to do is, now these two are parallel axis now. These two are parallel axis now. What I am going to do is, Ixx now 2, which is equal to moment of inertia about its central axis plus area of that particular quarter circle into now square of the distance between those two whole square. So this IGX is nothing but whatever I got as 71,88092 0.438 plus this value, okay, plus area of the quarter circle is 5 into r square by 2, okay, into now h2 is the distance between two parallel axes. Now what are my parallel axes? So this is gx is my parallel axis and xx is my parallel axis. So previously these are two, AB and gx are parallel axis. So previously why I have taken AB and gx are parallel axis means, in order to find out the moment of inertia about gx axis, I am only having the formulas from the base axis only. So base its own base axis I am having AB. Okay, from this one I got the central axis formula, central axis value as 71,880. So 7 or otherwise 7 crores 18 lakhs 8,092 meters mm power 4 value I got from this formula IGX. Now if I want to find out only about x axis only, so as stated in the problem. So that's only central axis plus, it means if you start from reference axis from here or otherwise from here, whatever the central axis moment of inertia is there, so it will be same only, but the distance will be varies. Now from the AB axis you are having from this AB axis you are having the parallel axis with the distance of 4r by 3 pi. But now about the base axis here, xx axis, about the xx axis as a total base axis, whenever it is involved with your rectangle, so from this xx axis if you want to find out, so moment of inertia, it is central moment of inertia about this particular axis plus square of the distance area into square of the distance between these two axes. So this total how much amount we are going to get? This is how much? How much means whatever the total height of the rectangle is there. So from this one, if you subtract this 4r by 3 pi, if you subtract this 4r by 3 pi, you are going to get. So total is 300. I think it is 300 only. Height is how much? Height of the rectangle is how much? The height of the rectangle is 120. Height of the rectangle is 120. So this 120 minus this 120 minus 4r by 3 pi. So 120 minus 4r by 3 pi whole square. So this is your central axis plus its area into whatever the square of the distance between two parallel axes. So this total value is the distance between two parallel axes. So parallel axis, one is your gx axis for quarter circle and xx where the total entire portion. So between these two, your 120 minus 4r by 3 pi is our distance. So where it is located, where the composite section is located. So from here to here. So this is your base axis and this is your central axis. So from here to here, this is the value of 120 minus 4 r by 3 pi. So if you calculate this one, how much you are going to get? So let's suppose, so this r should be replaced with 90. R should be replaced with 90. I am going to calculate so this value. So check it whether I am going to get correctly or not. So are you going to get correctly or not? So I will tell the value. So pi into r square, that is 90 whole square, divided by 2 into 120 minus 120 minus how much it is, uh, 120 minus 4 r by 3 pi, 4 into 90 r by 3 pi, so 3 into 5. After getting pi, you have to be 2 whole square, 4 r by 3 pi whole square. For total, you have to do the square. If you do this, 92, this total value I am going to get as negative. Only the thing is, if you do the calculation mistakes, sometimes no problem, but the concept should be very clear. So this value is 90. 92, 9 crores 23 lakhs, or otherwise 92 crores 32 lakhs 9,608 power 4. Power 4. But see here, this is not our ultimate aim. Our ultimate aim is to find out about the moment of inertia total, which is equal to Ixx1 minus, this is from the rectangle. So from this rectangle, moment of inertia about the same base axis Ixx2 per quarter circle also. So quarter circle also I have to denote. Then I will get the resultant, which is equal to this much. Okay, this much which I am going to get. So that is how much is the value. Actually, Ixx2 value I am going to get as 923296008.56 power 4. This is your Ixx2, but Ixx1 value I have calculated as per rectangle. So Ixx1 8 into 10 power 6. 8 into 10 power 6. This is 8 into 10 power 6. Now I will subtract 8 into 10 power 6. Somewhere we have done mistake. So this total entire value is going to be get as how much means how much it is means you have to be get the value of 120 minus 4r by 3 pi. How much you are going to get? So this total entire value. So this thing. So this thing I am going to replace 120 minus 4 into r by 3 pi. Okay. So this value, if you do this, you are going to get exactly how much means how much Ix is equal to, the value should be 47.39 into 10 power 6. This much value you are going to get. Okay. I hope it is very clear. Or if you face any problem, see what I have done is what I have done is what I have done is first of all I have taken rectangle area. Rectangle area I have taken and moment of inertia of rectangle Ix is one. BH cube by 3 I have find out. Okay. So why? Because this is for larger rectangle. So from this larger rectangle, so about this base axis, I know that the moment of inertia. I know that it is BH cube by 3. So this value I got moment of inertia Ixx, that is equal to how much I got moment of inertia about the base axis. So that is BH cube by 3 I am going to get. So BH cube by 3, that value should be, base is how much? It is 240 and H cube. H is how much? Your 120 whole cube divided by 3. So this value is how much? Your 240 into 120 whole cube divided by 3. So this value I got as 138240000. This much I got. So previously we got I think wrong answer. BH cube by 3, if you simply calculate it, and moment of inertia for central axis. For which one? Semicircle. So the semicircle like this one. So for center, in order to find out central axis, so from the base axis, I want to remove. I want to remove the area of this one. So moment of inertia about base axis 5 r power 4 by 8 minus area of this thing is how much? 5 r square by 2 area of the quarter semicircle into H2. H2 is nothing but, so see here from the base axis first of all. So it's total base, it's total own base. From the own base, if it is the centroid means this is the GX axis. So from here to here for the centroid is located 4r by 3 pi. So 4 into r by 3 pi. So if you calculate here, so pi into 90 whole power 4 divided by 8 minus pi into 90 whole square divided by 2 into 4 into 90 4 into 90 divided by 3 pi, which is equal to, now definitely here I got as 7201154.